So when we are talking about configuring Wireplumber, there are there are the like simple things that I think a lot of people kind of know about, like renaming your devices. As an example, I have Starship Matisse HD audio controller analog stereo, which is a very useful name for my 3.5mm jack. Or my mixer board here, the MGXU analog stereo. Or my favorite
Yeah.
one, Navi 2123 HDMI DP audio controller digital, which again that would be my HDMI port. Now, most people kind of know that you can rename devices, you can disable devices you just don't want to see. So, as an example, I would usually have my HDMI port disabled because I never listen to audio through my monitor. I will either use my speakers or my headphones. But what are some other interesting things you can do with the Wireplumber configuration that may not be something a lot of people kind of know about?
Yeah. So, well, the basic principle is, as I said, you have all of those events and you have all of those hooks. And what you can do is you can write your own hooks,
Mhm.
basically. And if you read the documentation, if you figure out exactly the order of which other hooks run and you understand what they're doing, then you can basically put your own hook somewhere in the middle and change things as the script goes.
Mhm.
So, for example, yeah, the example that you brought is one of them, right? If a device is creating some nodes, then you can basically go and add some Lua chunk there that basically changes the properties of that node before it gets created.
Mhm.
So you can take the name and swap it with something else, right? This is one thing you can do. Well, maybe it's a little bit more complicated than that for that particular use case.
Mhm.
But there are other use cases that work exactly like that. So, for example, let's say you want to select a profile for your card with some additional logic instead of having to select it on Pavo control.
Mhm.
You can very easily write a hook in Lua that will run just before the final apply function runs, and then in there decide if you want to keep Wireplumber's default or if you want to select something else based on your logic.
Mhm.
Same thing with selecting default devices, same thing with linking. So if an application connects and wants to link somewhere, you can either let Wireplumber take control and link it to the default output or the defined target object that has been defined by the application, or you can write your own hook, insert it there, and have it run its own logic,
Mhm.
which can be handy for some use cases, like if you have things that you expect to be running a lot daily and they are not being handled the way you like. Either because it's a strange device that behaves strangely and you want to manage it in a specific way, or because you have an application that behaves strangely and you cannot really change its settings
Mhm.
internally and you want some other logic to be applied there. These kind of things you can do easily with Lua scripts.
Mhm.
That's the intention. And additionally, through the all the Lua scripts are being loaded by the configuration file, so they are not being just loaded because they are in the directory. They are being loaded by the configuration file, which defines components. There's a section called wireplumber.components, which lists all the Lua files and all the modules.
Mhm.
And by tweaking that, you can also disable certain hooks from being loaded. So you can say, okay, I don't want this kind of logic to be applied, so you can take it off. And then you have the rest of the script running without that one being
Mhm.
loaded. Yeah, so that's the basic. These are the kind of things that you can do with scripting.
Mhm.
Now, there are limits to that. Unfortunately, we are starting to find the limits to where this can go nowadays,
Uh-huh.
with some more complex use cases that we have for specific devices. And we might have to at some point do another version where we even break things even further. So I've started thinking about, yeah, because even if you have an event that runs all those hooks, at some point it needs to take an action. So you have a new node being added, and then you run a bunch of logic, but then you have to take an action. And then you have another node being added and you take an action. And there are a lot of cases where that action depends also on the things that are going to come after. So you have to wait, you have to defer the action until you have finished loading a set of things. And we currently do that with the linking policy. So if we see that a new node is being added, we are expecting that maybe more nodes will be added. So we wait, we defer that action to later when the event loop is idle. But we're seeing more and more cases that this kind of separation is needed. And yeah, I'm starting to think that maybe we need to find a more generic way to separate actions from decisions. So to take a decision here, put it in a queue, and then apply the action later. And if a decision that comes later has to modify that action, take it off, replace it with another action, then we could also be doing that. Yeah, complex stuff, but it's what makes things work. We need to have a way to make informed decisions about what we expect, the graph to be like. And yeah, it's not easy at all.
Even though you say it's not easy, we're at a state now where, at least to the average user, things are kind of transparent. And I think that's a good state to be in, where unless you want to get like into the real technical weeds, I think we're at a point where the transition over to PipeWire and Wireplumber has been like, it's at a point where it's smooth. Because I was there at the like early start where Wireplumber was not recommended yet, where Wireplumber was just barely becoming a thing that people were talking about. And I remember it was there was some rough edges at the time. There were definitely some rough edges. And at least now, I have not had any major issues for I would honestly say quite a long time, a couple of years at this point. And I would imagine that most people are probably in a similar situation. And any of the problems they do have are likely coming from some other part of the stack. Like Bluetooth is Bluetooth. Bluetooth is, especially if you're in an area that has a lot of radio signals, right? Like you're gonna have problems.
Yeah, well, it's working though.
Yeah.
Bluetooth is one of the things that I'm proud of in PipeWire, that we have made it actually work for people instead of having them to fiddle with settings and whatever, and not having all the codecs. Like in Pulse Audio, it wasn't the case that these things would work out of the box. And with PipeWire, if you have interference, yeah, maybe that's a problem. But if you're in most cases, people just don't have any problem with Bluetooth. It will just work with any device, with any codec. It's just really good to have that working. And we are expanding. We are adding more features. So we are working on LE audio support, which is the new Bluetooth standard for audio. And there are some headsets that are starting to support it, and we have support in PipeWire for it already. Like before even the devices are out, we had support for it. I'm really proud of that kind of proactiveness in that area. But yeah, there can be cases where like people have problems if they have strange setups, or if they have I don't know, things like interference, things like just something that's not standard, and they're trying to fiddle with it, right? And some people are like that by default. Like they install PipeWire and they don't let it work as it is supposed to work. They want to fiddle with it from the beginning, and they say, oh, I want to configure this and this and that, and they start touching the configuration file, and then they break things. But yeah, that's human nature. And it's good that people actually have the ability to do it, and they have the ability to add functionality as well, to do more crazy things.
Well, being in the position you are, where you actually are working through reports that people are making and all of this stuff, how have you found sort of the, I guess, reception of Wireplumber change? Because I'm assuming early on you were getting a lot of basic issues that were coming along where, oh, this obvious thing is broken, this is broken. But as the years have gone on, how have you found that things have changed? Do you feel that people are generally finding weirder, more obscure bugs as opposed to things that should have been there from the start?
Well, the first observation that I can make is that we have less and less reports about things being broken or,
Mhm.
problematic. Of course, we still have some reports,
Sure.
and most of the time it's not easy to go through them and actually fix them. Like I actually don't have a lot of time to be able to make meaningful like changes most of the time, right? But yeah, for some of the cases, like we can look into them and try to go through. Thankfully, we have contributors who are looking at things, and they provide the patches and everything. Anyway, when we I would say that the reports that we are getting today are, yeah, they're a bit more strange setups, I guess,
Mhm.
or they are things that we already know they are problematic, and
Mhm.
people come up with, like, people report them because they are still struggling with certain things.
Mhm.
These can be coming also from different hardware, different devices being used. Um, I know we're not doing a great job at handling um, UCM devices, for example. UCM being the ALSA use case manager,
Mhm.
which is the new way, the modern way of describing devices
Mhm.
with. So ALSA has this thing where, as I was saying, where in the beginning of this conversation, it basically exposes devices in a way that you don't see what they are, we don't understand what they are. And
Mhm.
PipeWire tries to make up better user-friendly descriptions and separate the different inputs and outputs. But a lot of the time, it cannot do that without having some context of
Mhm.
what the device is, right? So it needs a little bit of context, and that context is provided in a configuration file, which in the past we were using this configuration format that came from Pulse Audio,
Mhm.
and in PipeWire it's called ACP. It's ALSA card profile, and that uses Pulse Audio logic, so it creates devices in the same way as Pulse Audio was creating them. And we are transitioning to UCM nowadays, where it's a standard way of describing devices directly in ALSA. So there's configuration files that ship with the ALSA libraries, and those configuration files describe the devices that we need to create on our side, and they are very different from what the Pulse Audio logic was. So, for
Mhm.
example, in the Pulse Audio logic, we had a profile where it would be analog output and input. And then if you wanted to switch to HDMI, you had to select another profile, which is HDMI.
Mhm.
And if you had multiple HDMI ports, you would select HDMI 1, HDMI 2, and every one of them was a different profile. And for every profile, the nodes of the other profile would go away. So if you were switching from analog to HDMI, the analog nodes would go away, and then you would have HDMI, right? So
Mhm.
you would only have one input output at a time. With UCM, it's not the case. We create all of them at the same time if they are not mutually exclusive on the hardware level.
Mhm.
And it's usually the case that HDMI and analog have nothing to do with each other, so that you can have them running in parallel and output to both. But depending on the device, you can have all sorts of problems there with that representation. And sometimes we come up with profiles to to mutually exclude devices, but they are obscure. They have obscure names. They have the switching also takes away the nodes that you had before and recreates them. Sometimes, like, you have an analog output and you switch profile, and the analog output is destroyed and then recreated exactly the same way it was before. Makes no sense, but that's how we do it nowadays. And yeah, this can lead to problems. And also other kinds of problems that I know we have is the naming, for example. Like you said it yourself, like you're frustrated about the names that you have on your devices.
Again,
and I completely agree.
If I clip this section for anyone who is unaware of the device I'm talking about, open up Pulse Mixer or Pavu Control, you see what I mean. Starship Matisse HD audio controller analog stereo. That's just one of my inputs. We can go to one of my outputs. Inputs are just as, actually inputs are worse, because then you have monitor of Starship Matisse HD controller, HD audio controller stereo, and I got a bunch of these. Yeah, they're not super useful names in a lot of cases.
Yeah, they're very strange names. And it's not easy to fix either, because different classes of devices have different ways of representing their names. And even in the same class of device, sometimes you find discrepancies. Like USB cards typically have, like, some will put the model in the description, some will put it in the name, some will put it somewhere else. And you have to scramble to find which one is the model and which one is the, company name and which one is what. There is no way to figure that out programmatically. Yeah, well, actually, one of the ideas I had there was, well, I don't know, what if we could run a very small language model to actually parse that information and get the context of what is what? That would be awesome. But yeah, I have no idea how feasible that is, or if it's something that we can pull off.
It's an interesting experiment. I would like to see the results of that.
It is. Yeah, I'm also interested to investigate that. But yeah, it's a problem. Like, there's no solution. There's no good solution, because the manufacturers of those devices don't follow a spec, basically.